All right, here we are, 5.1. We're going to do examples on particle motion. You might need your notes from the first page right next to you. So what we need to review or remember is that position is our first equation. So y equals the position function. I'm not going to say y equals. Okay. And then y prime, the derivative. So the derivative of position is what? Velocity. Okay. And then the derivative of velocity is acceleration. Okay. So this is how it's going to work. Sometimes we'll be given the position and asked questions about the velocity and acceleration. And sometimes we're given velocity and then asked questions about velocity and acceleration. You ready? Here we go. What are we given in example 1? What are we given? Velocity. Find the values of v of 3 and v prime of 3. Based on these values, describe the speed. So we're going to need to know what speed is from our notes yesterday. Ready? V of 3. How do we find v of 3? Plug in 3 into the velocity function, yes? Here we go. Just make sure you add correctly. What's 3 plus 2? 5, and 3 plus 4, 7. Are we going to multiply or do the exponent first? Exponent. So it's going to be 5 times 49, which is 245. And are we given units? Sometimes we are and sometimes we're not. Do we have units for this? Inches per minute. So velocity, this particle is traveling 245 inches per minute. Now, sometimes the question will just say find v prime of 3, but before you can plug in a number into the derivative, what do you have to find first? You have to actually find the derivative. So the derivative of the velocity function here, what rule will we use? Product rule with a little chain rule that will be a disappointing chain rule. Okay, ready? Here we go. The first. So the first will be t plus 2. If you're wondering, the t is just like x, okay? So we just pretend it's x. So the derivative of t will be 1, like that. Okay. Back to our product rule, sorry. F g prime. So the derivative of this, we're going to bring the 2 down in front. The inside stays the same. And what's our new power? 1, and then we multiply by the derivative of the inside, but the derivative of t is 1 and the derivative of 4 is 0. So what did I say? Kind of a disappointing chain rule, right? We didn't actually, we have a power of 1 and a multiplication of 1, so nothing exciting. Are we finished with the product rule? So to finish the product rule, we have fg prime plus g, t plus 4 squared, f prime. So what's the derivative of the first factor there? 1. All right, there's our derivative. We don't need to clean it up, all right? And this is kind of what I told you a month or two ago. Like, we don't have to multiply it all out because what's the goal of this derivative? The goal is to plug in 3, yeah? So we don't need to simplify it in order to plug in 3. We're just going to plug it in. There used to be a commercial a long time ago for Glade plugins. I went, plug it in, plug it in. So math teachers for like 10 years just sang that song. But when I sing it now, people just look at me weird. Plug it, okay, 3 plus 2 is 5. Are there days where you add correctly and then other days where just not add correctly? Okay. So what is 5 times 2 times 7? 70, and then 7 squared. So we did multiplication and the exponent before we add. 70 plus 49 is 119. All right, a while back, but it's been a while, was that every time we take a derivative, what happens to the units? So so if you're in physics, you already know the units for acceleration, but every time we take a derivative, the units divide by time. So if we have inches per minute, and we're taking the derivative of that, it's going to be inches per minute, or inches per minute squared. We say that, okay? All right, look at your notes. What is speed? We have kind of two things to talk about for speed. Speed is what? Absolute value of velocity? Okay, do we have velocity? Yeah, we have it here. And it's already positive, so speed is also, so speed will equal positive 245 inches per minute. But is this speed increasing or decreasing? That's what we need to go look at your notes. How do we know when speed is increasing or decreasing? All right, so if velocity and acceleration have the same sign, they're both positive or they're both negative, that means the acceleration is helping the velocity go faster, helping the particle go faster. Same direction, that means speed will be increasing, but opposite forces. So if velocity and acceleration are going in opposite directions or opposite signs, then speed will be decreasing. So you tell me, do you know that this was acceleration? Why was it acceleration? So we had the derivative of velocity evaluated at 3, so that's the acceleration at 3. So if the acceleration is positive and the speed is positive, what is our speed? Increasing. And the reason is v of 3 and a of 3. We can either say they have the same sign, or we can be more correct and say they are both positive. If you say same sign, it's like you don't know if they are positive or negative because are both positive. All right, questions? All right, let's look at example 2. This is directly off an AP exam from one of the years. An object, instead of particle, moves along the x-axis with an initial position. We won't need this until we learn how to take the antiderivative later in the year. So this is like extra information for this question. We don't really need this. It just means that when time is 0, it begins at 2 units to the right. That's the starting position. The velocity of the object at time is greater than or equal to 0. One thing I like about this is that time is always positive, so we don't have any negative x's or negative time. And it's given by this function, sine of pi over 3t. You ready? Here we go. What's the acceleration of the object at time equals 4? So if we're given velocity, how do we find acceleration? Take the derivative. Yep. So how are we going to label it? Let's label it. Okay, this is a big no-no. Ready? Do not write this down. The acceleration at 4. That's bad because before we can plug in 4, we have to find the acceleration function with just t's, okay? So a of t will equal v prime of t. So the derivative of velocity is acceleration. So make sure your labels are correct. Messy test. Last exam, you weren't labeling what you were doing. You have to be crystal clear. I am doing this. Okay, what's the derivative of sine? Cosine. So this is a little chain rule. The inside stays the same, and we're going to multiply by the derivative of the inside. So on the inside, if we have pi over 3t, It's just like 2x would be 2. Well, this is pi over 3t, so the derivative is pi over 3. So now we can find what is the acceleration, a of 4. So we're going to plug in 4 for t. So anytime we have pi over 3 times a number, we just change that to 4 pi over 3. Pi over 3 times 4 becomes 4 pi over 3, and then I need to multiply by this. Okay, do you remember the unit circle? Remember, it just pops up out of nowhere, right? We have a few weeks without seeing it, and now here it is again. What quadrant is 4 pi over 3 in? Do you remember? So this would be like 1/3, 2/3, 3/3. 3 over 3 is pi here at 180. So 4/3 is down here in quadrant 3. And what is this first coordinate point here is 1/2. 3, and then square root 3 over 2. So it's going to be the same coordinate point over here, except what? Both negative. I think I have room to write this. Okay. So the acceleration at 4, notice this was right off an AP exam. I wanted to let you know, do you see how there's no units for this question? The AP exam doesn't use units for these. It's silly. Okay. So the cosine is negative 1/2, but we still have to multiply by pi over 3. So final answer for acceleration, negative pi over 6. Negative pi over 6. Any questions? Okay. Here we go. Consider the following two statements. Are either or both of these statements correct? For each, provide a reason. So when time is between 3 and 4.5, do you agree that 4 is between these two? Yes. The velocity of the object is decreasing. How do we know if velocity is decreasing? So this is really confusing. You got to be careful of your words here. This is not talking about speed. Speed and velocity, two different words. Velocity will be decreasing if acceleration is negative, because velocity is decreasing if acceleration is, negative, because acceleration is the derivative of velocity. So is the acceleration negative at 4? Yes. So velocity is decreasing because a of 4 is less than 0. Now we have the word speed. Speed will be decreasing for a completely different reason. So we have to use the definition on our notes. So speed is decreasing if velocity and acceleration have opposite signs, increasing if they're the same sign. Okay, so if speed is decreasing, that has nothing to do with slope. We're talking about same sign or opposite signs. So do we have the sign of acceleration at 4? Yeah, but do we know what velocity at 4 is? No, so we need to find that. Okay, so find v of 4 by plugging in 4 into the velocity function. That's the original up in the question here. But don't we already have this coordinate point? And do we even need to know what it is, or we just need to know that it's negative? the y value at 4 pi over 3, is negative 3 square root 3 over 2.